Okay, welcome to Lesson 9-9. I've got Graham as an innocent bystander sitting here doing some work in my classroom, so he may or may not join in and be a guest, but I definitely have Molly who's going to be joining us, and we're going to be talking about the exact same three-dimensional objects that we talked about over the weekend, which was prisms and cylinders. So those would be, prisms are the ones that have polygons that go straight up, and cylinders are the ones that have circles that go straight up. And we actually kind of got these lessons backwards, or at least the book did, I think. Because when you had to do the surface area of a prism or a cylinder, you had to break down all those pieces. You had to essentially break it apart into its net and kind of picture it and figure out all the different parts, and then you had to add it all together, right? And so hopefully last night, or hopefully tonight, you're finishing those up if you're still having trouble. But basically that was the idea. You had to find the lateral area, which was the big rectangle that wraps around the whole prism or cylinder. And then you had to find the base area, and you added those in on the top and the bottom. It is so much easier to find the volume of prisms and cylinders. Are you ready, Molly?
Yep.
Okay, watch how much easier it is. Here is the formula. The volume is equal to capital B times H. And the only reason that the B is capitalized is because this doesn't stand for a base side, it stands for a base area. Okay? That's literally all you do. For a prism or a cylinder, you just find the area of the base, which I could show you up here on the top. The base doesn't have to be the bottom. It's just one of the shapes. And then you multiply by the height. Okay? So if I come over here, and let's say both the cylinder and the prism over here have a height of h, okay? And they have a base area of b. So this one here is b on the bottom, and this one's here b on the bottom too. They would both have the exact same volume. Capital B times h. Okay? That literally is it. So Graham, I know you're not really participating, but go ahead and name a radius for me for a cylinder. 4. Okay, we'll say it 4. We haven't used inches in a while, so let's use 4 inches. And if the radius is 4, Molly, it looks like the height is about twice as tall as that, right? Yep. So why don't we make the height equal to 8 inches? Okay, you ready? Here, yep. We're going to find the area or the volume of the cylinder. So we're going to do B times H. Well, what's B? Well, if the radius is 4, then we're going to multiply 4 times 4, which is 16, and I'm going to get 16 pi. And the height was 8, and so 16 times 8, that's the hardest part. 6 times 8 is 48. Carry the 4, I get 124 pi. That's the answer. That's the volume. I'm done. Okay? If the height... Here, let's switch to a different color here. How about white? Yeah, we'll use pale pink. We never use that. Or pale purple. All right. So, Graham, you told me 4. You didn't see the picture when you said that. So if that was 4, how wide do you think that is? Maybe a little bit more. Maybe call it 5. Mm-hmm. And let's make it a square. Let's make it 5 by 5. Is that good, Molly? Yep. And let's let the height stay the same. Let's let the height stay 8. So all we're going to do to find the volume of this is we'll write the formula down. So it's capital B for base area times height. Okay? Well, what's the base area? What's 5 times 5?
25.
Times height, which is 8. What's 25 times 8? It's 200. And let's keep this consistent. This over here was inches, so this really should have been inches cubed because it's volume. And this is also inches cubed. And that's the volume. That's it. You put a box around it. You're done. That's all there is to it. Isn't that a lot easier than doing surface area? Where you don't have to find like the lateral area and the base area and put them together. So you find the area of the base and you multiply by the height and you are done. Yes, Molly, you have a question?
It's not about little.
Okay, let's stay on this. All right, so here, ladies and gentlemen, thanks for tuning in. I'm going to give you two figures. I'm going to give you another rectangular prism. And this one's rectangle because the sides are not the same, so you're going to have to be a little more careful. Not really much, though. And then here is a cylinder with a radius of 3 and a height of 4. So pause the video and find the volume for each of these. Remember to start with the formula. The volume equals capital B times H. As soon as you have your answer, make sure you put your units in. So why don't we say, what do you want to measure in? Pick a unit.
Centimeters.
Centimeters? Okay. We'll use centimeters for the box, and Graham, pick a unit for the cylinder.
Inches.
Inches, okay. And we'll use inches for the box. So these are both in inches. These are all in centimeters over here. Okay, pause the video, find the volume, come back and see us. All right, so let's go ahead and do these. So the volume here is base area times height, right? What's the base area? Well, if it's a 3 by 4 rectangle, what's the area? You just multiply 3 times
12.
4? Yeah, 12. Times the height, which is 8. And 8 times 12 is 96. And this was in centimeters, so it's centimeters cubed. That's the whole problem.
Easy.
Okay, the cylinder, the volume is base times height. Now, if you want to, you can actually write a more specific formula here. You could write pi r squared to remind you how to find the area of a circle, especially if you're having trouble with it. Okay, and so pi r squared is pi times 3 squared, which is pi times 9, right? And the height is 4. And so what's 4 times 9?
36.
Volume is 36, and this was measured in inches cubed, and we are done. Oh, I forgot the pi. 36 pi inches cubed. That's it.
Easy.
That is the whole problem. All right, and so that is 5 minutes. Good job, guys. We're going to practice these in class. So class, thank you very much for watching, and Molly and Graham, thank you for helping me. And we'll practice bunches of these tomorrow, but honestly, I would strongly argue, and I think you both agree, finding the volume is actually easier than finding surface area.
Yes.
So, all right, with that, we're going to sign off.